Second time also constructor call. Then again constructor logic to execute one more stack frame is created. So as many times you call static block or method or constructor, those many stack frames are created. So tell me, for one program execution, how many stack frames are created for static block? Only one. Static block, how many times executed? Only one. For main method execution, how many stack frames are created? Only one. For static method, non-static method execution, how many stack frames are created? As many as you call. Static method, non-static method, as many times you call, those many. Next, for a constructor, how many stack frames are created? That is also depending on how many new objects you are creating. As many new objects you created, those many times the constructor must be executed, those many times stack frames are created. Does everyone understand? Okay. Now can you please write on this program and diagram now? Take a read. Draw JVM architecture. Draw JVM architecture to show. Draw JVM architecture to show methods execution flow. To show methods execution flow. To show method execution flow by creating stack frame. By creating stack frame inside a thread. By creating stack frame inside a thread. Yeah, write on this code. Completed? Now, so can you write this JVM Java stack area? The main thread, inside main thread. I hope you already completed main thread this stack frame also, right? Right, step by step the arrow marks. And M2 method also destroyed, control will go back. Then next line completed, main method stack frame also destroyed. Then main completed, main thread completed, JVM also completed. So if you are done, please let me know. Okay, I have a question. Is the M3 method stored inside JVM? I am asking question, is the M3 method stored in JVM memory? Okay. Is M3 method, for M3 method, is the stack frame created in method in Java stacks area? Stack frame is not created, correct. Then is the M3 method stored in JVM, loaded into JVM? Arey bhaiya, M3 method is part of example class. If example class is loaded into JVM, M3 method is also loaded, na? Heart is part of your body. Brain is part of your body. When your body is moving from one place to another place, along with your body, all the parts of your body also moving, na? Right? You are not dropping some parts in your room and not going anywhere, right? After going there you are using which part is depends. You come to the class. To the class you are coming with your brain and other parts. But in the classroom what you are using? Only eyes and ears. You never use brain. Are you catching my point? So same story here, okay? M3 method logic is loaded into JVM along with the class. You cannot stop loading it. But in Java stacks area, in main thread, M3 method stack frame is not created because it is not called from main method. Understood? Right on that point. M3 method is loaded and stored inside JVM. M3 method is loaded and stored inside JVM. But stack frame is not created for M3 method. But stack frame is not created for M3 method because we didn't call M3 method. because we didn't call M3 method. Okay. Right. This topic understand? Can I take a method inside main method? What is the meaning of it? Akshat, what is the meaning of your question? Okay. Now let's move to the next topic. Look at here. Look at this code and try to answer what is the meaning of it, what I am trying to do. Up to now we have learned how memory is distributed. Okay. Then inside, if a method contains a logic inside the method, then how that logic is executed inside JVM? Let us try to understand it more. Okay. Tell me now, as per regular flow, what happened? A variable memory created with value 10. B variable memory created with value 20. C variable memory created. To initialize C variable, the expression A plus B is executed. Okay. Then result generated, result stored in C variable. And then C result is displaying on console. So here totally, in a method execution, there are totally 3 parts are there. If we carefully notice, there are 3 parts are there. Part number 1, parameters and local variables memory. Int A, int B, int C. Part number 2, to execute this method logic symbolic references mapped with the actual references in constant pool. Yesterday I shown you, remember? So the symbolic references are there in the constant pool. That means this add method execution purpose, frame data is created, stack frame is created. This stack frame related data is available in constant pool. That frame data has to be retrieved and stored here. Every time it cannot go to the constant pool to take the data. So first it has to store, for executing this method, first it has to store parameters and local variables. Then it has to store frame data from constant pool. Third, then logic should execute. Tell me, logic execution means what? A plus B. First it has to read A value and substitute. Read B value and then substitute. Then execute plus operator. Then result store. Then return. So this is called the actual flow of execution, the actual logic execution, step by step. First you read A, then read B, then perform plus, then regenerate result. So what is this? It's a real stack. Step by step operation performing is nothing but what? Stack operation, right? This is a real stack. Are you guys understand what I'm saying? This is the real stack. Then now finally try to answer. A method logic execution is divided into how many parts? 3 parts. The first part is parameters and local variables memory allocation part. Number 2, frame data storing part. Number 3, method logic execution, method stack, method stack. Okay, right. So now let me draw the diagram for you to visualize. This is the stack frame. For add method execution, stack frame is divided. This is a thread. Let me write full. This is a thread. Inside thread, for add method execution, stack frame is created. Now this stack frame is divided into how many parts? 3 parts. Number 1, local variables memory creation. Number 2, frame data. Number 3 is what? Method stack. Now this is one stack. Now tell me, is it easy for us to differentiate from one stack frame to another stack frame? Because again each stack frame is divided into 3 internal parts. So where stack frame is started, where stack frame is end, okay, that's a confusion. This is the actual diagram is given by Sun Microsystem. Then I have recreated this diagram for our understanding, no problem, we can do that. Now this is thread. Inside thread, this is a stack frame created. Okay, now this stack frame I divided into 3 parts like this. For our easy understanding, I divided like this. Now it is easy to differentiate one stack frame from another stack frame. And our same architecture following by market. I told you now, JVM architecture, I am the one introduced to the market and people are following us. Okay, no problem, I'm happy for that. Now, what is this first memory? First part is called what? Local variables storage area. Local variables means parameters also. Parameters and local variables storage area. So inside a stack frame, where parameters and local variables stored in one place, that place is called parameters and local variable storage area. This is second part is called what? Frame data. Frame data storage area. Frame data storage area. And here this is called what? Method stack. This is method stack, where your logic will be executed. So totally a method execution is divided into how many parts? 3 parts. Is it clear to all? Now let's start understanding. So this is what? Java stacks area. Inside Java stacks area, what is this? Main. Inside main thread, main method is here. Main method is also divided into 3 parts. And here you call what? Add method. When you call add method, now add method stack frame is created. Inside add method stack frame also divided into 3 parts. Then first statement executing int a equal to. Then what happened here? A variable memory created with value. Then B variable memory created with value 2. Then C variable memory created. Okay. Now in C variable, is directly A plus B stored? No. Then now A plus B execution is an operation. Here in this method stack, now to load and store A value, what I told, read A, substitute. Now read A value and substitute here 10. Then next B value read and substitute. Then Uh, then plus. Tell me, is a plus is a plus is a plus understood to the JVM and is a plus understood to the operating system? No. For plus, there is a one command called iadd. What the meaning of iadd? Integer add. Okay, integer add. Now iadd is loaded in. iadd is nothing but a command that is available in same data from there loaded. Okay, right, iadd. Then now this iadd command is adding 10 and 20, generates the result what? That is stored. Now this 30 will be written and stored inside our C. Okay, now is everyone understood? Look at here. Here also we are having a stat frame is also having multiple blocks here for storing values and operators to execute. These blocks are technically called slot. What it is called? Slot. Now each slot is having the memory of 32 bits. It is called slot of how many bytes? 32 bits. 32 bits means how many bytes? 4 bytes. Okay. Okay. Shall I ask a question? Now tell me. Here, in place of int, I am using long. Then, how the program execution will be? Out of it. That you cannot use long for doing calculations. Tell me, what are the changes will become in this diagram? To store this value 10 here, how many bytes required? 8 bytes required. But how many bytes of slot is created? 4 bytes. Then for storing long value, how many slots are created? 2 slots allocated. Understand? If we use a long based operation, inside 2 slots are allocated. And what is the command? Command is not iadd, command is what? Ladd, long add. Is it clear to all? Next, suppose in place of long, I am taking what? Byte or short or char. Okay? If you take byte or short or char, then what happens? This A plus B operation will lead to compile time. Why? Now look at the diagram and tell me. A plus B operation leads to compile time error. Why? There is a statement in Java. Every arithmetic operation, the result is int by default. Why? It is automatic. Okay, na? Generally people say in Java by default every arithmetic operation result is of int type. By default int type. By default int type. Tell me that statement. Why by default int type? Can you tell me the secret now? Now tell me this A is how many bytes of memory? 1 byte. Now 1 byte value can loaded into slot. What the slot minimum memory? 4 bytes. Then this 1 byte 10 promoted to 4 bytes. 1 byte 20 promoted to 4 bytes 20. Then I add, generate the result and store it in this slot. In this slot, 30 is of what size? 4 bytes. Now C's variable is of what type? 1 byte. Tell me 4 bytes data can store in 1 byte? No. Actually, A plus B will not error. Sorry, I gave a wrong answer. A plus B is not error. Sorry, A plus B is not error. A plus B assignment. A plus B assignment will lead to compile time. Why compile time error? Because the assignment result is of what type? Int. Why it is int? By default, every arithmetic operation result is int because the internal memory is used for storing result is of what type? Int type. Does everyone understand? The internal memory used for storing a result from an expression is of 4 bytes memory. That's why every arithmetic operation result is of type int. Okay, comfortable? So this is the complete details about JVM architecture and its internal secrets. Hope you all enjoyed these secrets. So how much knowledge you required for working with JVM? That much knowledge I shared back. Please write on this. Seven o'clock to 8 o'clock, you don't have message there because join class by using another link. What happy teachers, man. Then how do you know that you have to join the class here in this link? At what time they have show meeting ID password? recording and left the class, right? Tell me the truth. You joined in the app, kept the class recording, and left the place. And you return at 8 o'clock or 8:10 to see what is happening. Sound is not coming. Then finally you saw that message and join this class, right?
No.
No, it is like that only. I know it. I know you guys what you are doing. I'm not that much fool. If you feel it is important for interview purpose, you must stay at the system, not kept recording and left. Only people will feel but not showing actions. Guys, what the meaning of AO? AO means arithmetic operation. What the reason by default? Because the internal slot size is 4 bytes. What possibility, man? For you again, you want me to teach you. Hey guys, completed, huh? I am working hard to build a career. You are working very hard to record the classes. So why I should work for you today? Tell me. You people are working very hard in recording, not learning. I am not recording anything here to share. If you say sorry, what I can do, man? I don't want sorry. If I have something I can give you, I don't have anything. It's live class. It's not recorded class. Definitely, I'm telling you, technology one day kill you. Technology will create problems to you. So now it's a live example. Okay. Size is 4 bytes. What will be there in other 2 blocks of main. Where 2 blocks? Raghavendra, which 2 blocks you're asking? Same architecture repeated for main method also, na? This is main method parameters, variable storage area. This is main method frame data storage area. This is main method stack frames, all stack frames, slots. Method main method stack. Okay. So this architecture is repeated for every stack frame of every method. It's not for only add method. Just I gave you add method purpose. Remaining things you have to apply them. Okay, all people completed. Because Gupta, again you are saying same statement. I didn't do any mistake. I shared the information yesterday, day before yesterday, joined the class by using temporary link, what I have shared in the class. Number two, I didn't ask you to join in the app, you joined, that mistake you did. Number three, I already posted in the morning 7 o'clock only in the Telegram app. Okay. And by 7:30, I asked my team to place the messages to join this temporary link. I gave all information. You are not there. You have to accept that. Still, you are saying that all bluff things. Don't lie. Every information I gave since morning 7 a.m. onwards, I am giving information to the students. Clearly, I am giving. So you are busy with your work. Then what I can do? Tell me. You are habituated regarding the classes and enjoying with the classes. Not like not attending the class live, so that you will miss the important information. Okay. Yeah, Manoranjan. This slot will be 4 bytes. If you take a double, 2 slots of float will be created. For floating point, float. So at least now change from recording videos to come to the live classes, so that it will be good for all. Char also same, man. Char is part of what? Int. You take byte or short or char, same point apply. For Boolean, not aware. For Boolean, it's just take 1 byte or something. Okay. String internally character, na. String is a class internally holding data by using character. Okay, chalo. So this is the story about JVM architecture. That's all. JVM architecture story complete. So now please open material. For tomorrow, bargain. Right. So JVM architecture, it's a time you have to read this book. 20 pages are there. All 20 pages you have to read. JVM architecture, introduction, then what is virtual machine, advantage of virtual machine, then types of virtual machines. JVM is a process-based virtual machine. Why it is process-based virtual machine? You should have an idea. And features of hotspot. So what will happen when we run Java command? Class loading phase. Now all the different phases. Okay. Then class loader subsystem in the JVM architecture diagram with all 4 components. And then class loader subsystem, how it is working. Okay, what are the different class loaders and their purpose. And then class loader working functionality, and then a small program to show you class loaders, then class lifecycle, loading, linking, and preparing phase. Next, runtime data yes explanation. And yesterday, Sunday class, I have explained this diagram. Okay, all the steps with respect to above diagram, all the steps I gave here. Then how class bytecode is exactly stored in JVM, I'll explain the coming classes. This one not required at this stage. And then about Java framework, Java stacks area. Today I have explained, right? Java stacks area. Today I explained this point. For each stack you created in the Java stacks area, one program count register and one thread will be created. Okay, totally 7 points I mentioned. You can read thread architecture. Today I explained. Okay, and then with respect to above diagram, what is happening? Okay, and then stack frame architecture. Okay, so that is the story about JVM architecture. Okay, about program counter register, about native methods area, there is not much to understand. Just small points are there. If you want, you can read these points. Execution engine contains all 5 parts. Okay, then this is a JVM architecture final diagram with conclusions. So you can make the diagram by your own, you know already. So if you really wanted to learn more details about execution flow of your bytecode, do 3 things. After every class you compile, read its bytecode by using below command, java p-verbose class name. If you want to know more details about your class and its execution flow, every program you compile like this. And after compilation, read bytecode. Then study a book called Inside the Java Virtual Machine by Bill Banners. I gave you sufficient knowledge. If you want more knowledge, read this book. Already I shared in the Google Drive. Okay, so this is the story about JVM architecture. Now let's move to the next chapter, static members and their execution flow. Yeah, the next important chapter, which will play most important role in your interview. If you want to pass written test exam, okay? If you want to pass written test exam, if you want to find output of any program by your own, this chapter playing very, very important role. Why all your seniors are forcing you to join my class? Why I have this much craze in the market? It's only because of 3 chapters. Number 1, JVM. Number 2, static members. Number 3, non-static members. Okay, these 3 chapters will make you 100% strong in, finding output of the program by your own and passing the written test exams. So this chapter and the next chapter is very, very, very important. Okay, na? Right. So in this chapter, totally there are 150 plus entry questions are there. So shall I cover all questions? Totally 150 questions are there. Shall I cover? It takes around 4 days. No problem. Let's start. Now tell me, in this chapter we are understanding all these topics. Let's say 50. Yeah? Okay. Let's meet tomorrow. Tomorrow also join the class by using the same temporary link. Okay. 11 a.m. batch students, it's up to you. I completed JVM architecture. Then remaining topic, this chapter, if you feel you are good in this chapter, you learned everything, then no need to join tomorrow. So if you feel you need revision, then you can join. Your wish. I'm not forced. So JVM architecture chapter not covered, I covered. If you feel everything is learned in this chapter, you know everything, no need to join. So tomorrow also join the class by using this same link. Thank you.